Hi everyone, my name is Brian Slajeski and my team and I are going to present our final project on our ultra premium long range business jet. First, we are going to take a look at the background for private jets. Why do people fly private versus first class? Privacy, schedule flexibility, and in-flight amenities are the biggest reasons. The customers for an ultra premium private jet are some of the richest people in the world and are likely very famous as well. This would include people like Michael Jordan, Taylor Swift, Leonardo DiCaprio, Bill Gates, etc. They cannot fly commercial because their fame would cause issues at the airport with boarding and security, and it would be extremely time consuming for them to meet with everyone that wants to take a photo with them. People of high net worth are generally very busy and their time is extremely valuable. Having the ability to schedule your flight around your busy schedule rather than catering to the commercial airliner schedule is a must for our customers. On top of the ability to schedule flights, owners can also change, add, or cancel flights if anything changes, since the plane is a tool for the customer, not the airliner. Having this level of flexibility and absolute scheduling authority over your travel is an absolute must for our customers. Due to frequent and long travel, our customers need to have significant amenities while en route. Whether it is sleeping, eating, showering, working, taking a phone call, or as simple as having a private conversation with a friend, the plane needs to be able to do all this at any moment. First class commercial airliner simply cannot compete with the amenities that a private jet can offer. Customers need all of this and more with a real focus on bespoke, customizable, high quality interiors. They also expect the best customer service due to the high cost of these planes. One aspect of customer service that is very important is maintenance. Making the plane serviceable anywhere in the world is a big task, but it emphasizes how important it is for the plane to be available to the customer as much as possible to fit their schedule. The other part of customer service is pilots and flight attendants. They need to be highly trained professionals that are at the top of their field.
Hi, my name is Triyasha Sarkar, and I'll be talking about the current competitors that are right now on market for ultra premium business jets. Before we dive into the details of our design, it is important to understand the competitive landscape we are operating in. On the left, we have Gulfstream, a well-established leader in the ultra premium business jet space. Their G800, G700, and G650ER models are benchmarks for performance, cabin luxury, and long range capability. These aircrafts are optimized for speed and intercontinental range while delivering a high touch interior experience. On the right, we have Bombardier's Global Series, the Global 8000, 7500, and 6500, which push the envelope in terms of range, interior cabin width, and in flight technology. The Global 800, in particular, boasts one of the longest ranges available in the market today. Designed for executives who demand seamless travel from destinations like New York to Hong Kong without refueling. Both of these companies deliver exceptional aircraft, but here's the key: none of them fully integrate sustainable propulsion solutions or offer modular cabin architecture tailored to changing user missions. That's our white space. That's where we differentiate. Our design leverages next generation hydrogen electric propulsion and a reconfigurable cabin interior, giving us a technological and experiential edge. We're not just matching what exists, we're redefining what premium business aviation can be.
Hi, I'm Felipe Berlina, and me and John will be covering just how we plan to beat our competitors. So this is the morphological matrix that we ended up creating for this aircraft. You can see our subsystems there on the left, options on the right, and what we ended up choosing on the right for each subsystem in bold. I'll be going over specifically how we came up with the options for the propulsion system, and John will be going over how we ended up with each of the options that we had decided for each subsystem. So for the propulsion system, the first three are pretty standard. So the Rolls-Royce Pearl, GE Passport, and PW800 are already being used in our competitors. They're all two spool turbofans burning jet fuel. They're pretty common, um, and they're building on technology that has been around for quite some time, and actually technologies that have made these companies pretty rich and pretty large. Um, as a small startup like us, it's kind of hard to compete against those guys if we go toe to toe with them directly. Where we can really see a benefit over such a large company is in our size. As a small company, we have the ability to structure ourselves from the ground up in a way that we see most fit. Specifically, we as a company have decided to leverage a lot of the new developments in systems engineering in order to really push the boundary in technology, and that's what we wanted to do with this company. Um, because of that, we started thinking outside of the box, and we ended up coming up with entertaining the idea and eventually choosing um, the hydrogen electric propulsion system that you see there, the HEP1 thruster that we're calling it. Outside of just pushing the boundary, just doing it to do it, there are quite a few benefits over burning avgas. For one, um, it is significantly more environmentally friendly. So instead of burning long hydrocarbon chains like you see in aviation fuel, in jet fuel specifically, where you're burning it and you're getting out these carbon oxides, carbon monoxide, carbon dioxide, that type of thing. When you burn hydrogen, you're just getting water as an outlet, which is significantly more environmentally friendly. Outside of that, it does give you the ability to increase your range. Hydrogen has a pretty high energy density, especially when compared to jet fuel. So you do increase your range that way. So that's why we decided to go with that option.
I'm John, and I will be talking about some of the features that set our aircraft apart from other business jets. The most important feature are the dual hydrogen electric engines that will be mounted on the aft fuselage. Through a Pew matrix, we were able to determine that the HEP1 engines were very competitive with the Rolls-Royce Pearl engines. The main metrics we focused on were weight, efficiency, size, and maximum thrust. A Pew matrix is a good technique to get a quick glance at the advantages of each potential propulsion option, but to get a more in-depth look, we conducted a Topsis analysis focusing the most weight on the aircraft's weight and its efficiency. These metrics are most important as they play the largest factor in maximizing the range of the aircraft. The cockpit also has some interesting features, including the heads-up display to assist pilots during low visibility conditions. It also has the Garmin G5000 flight deck and a jump seat for additional crew. The last thing that I will discuss that makes this plane stand out from our competitors is the cabin. The cabin has endless possibilities and is capable of seating at least 8 people in any configuration. The interior also has the capability of holding a queen suite and a handicap accessible bathroom. These features are some of the things that set us apart from our competitors and make us the best business jet in the industry.
Hi, I'm Bo. Next, we're going to talk about the risks and mitigations. Here's how we have broken down our timeline and action plan. In phase 1, which covers the first 3 months, the focus is on validating the external design and doing some early cabin testing. This helps us log in our basic layout. In phase 2, around months 4 to 6, we move to more technical testing like engine bench tests to make sure we meet ICAO Chapter 14 noise standards. We are also planning to finalize our FAA Part 25 certification plan during this stage. And finally, in phase 3, from months 7 to 12, we will start prototype taxi testing. That means we will have a working aircraft on the ground, validating the systems like brakes, steering, and controls. This plan gives us a clear path from design through to a test-ready aircraft.
Now let's discuss risk, which is one of the most critical aspects of aerospace design. Our risk assessment combines both probabilistic and knowledge-based uncertainties to proactively plan for potential disruption across the lifecycle of our ultra-premium business jet. We have evaluated each risk by likelihood and consequence on a scale from 1 to 5. Let's walk through the key ones. The first is cost overrun during development. This is a high likelihood, high consequence risk. Air development frequently runs over budget due to supply dynamics and material volatility. The mitigation to this is we rely on historical cost data, rolling forecasts, and built-in contingencies to safeguard financial planning. The second risk is failure to meet cabin noise reduction targets. Silence sells in luxury aviation, but acoustic design is complex. It is technically difficult, yet essential for ultra-premium branding to create incredibly silent accommodation. We have planned early-stage simulations and mock-ups to address this during preliminary design. The third risk is regulatory delays in certifications. Certification delays can derail even the best aircraft if not planned for it. We have proposed a dedicated regulatory liaison team and buffer schedules to reduce this epistemic uncertainty. The fourth risk is insufficient market demand post-launch. The ultra-premium market is highly sensitive to global trends. In order to have a mitigation strategy, we have built one of the most important mitigation strategies, which says through robust market analysis and modular customization, we aim to increase flexibility and long term appeal. The fifth risk is underperformance of new propulsion technologies. Our hydrogen electric architecture pushes boundaries but also carries uncertainty. Performance objectives might be severely hampered by underperformance if sophisticated propulsion technologies are included, such as hybrid electric. That's why we have embedded TRL evaluations and fallback propulsion modularity into our architecture. The sixth one and the most important one is the plane crash one. So statistically, it's quite rare, but the consequences are catastrophic. Hence, advanced pilot assist systems and autonomy features are designed to minimize human error, currently the leading cause of private aviation accidents. What sets our team apart is not just identifying these risks, but designing them with them in mind. By layering proactive mitigation into the very core of our concept, we reduce surprises and build a safer, more reliable aircraft.
Okay, let's talk about the verification requirement. First, in systems integration, the avionics and the cockpit systems teams will conduct the connectivity demo and the cockpit test to verify our integrated cockpit systems, including Starlink compatibility. Next, environmental testing will include the pressurization test and acoustic chamber test, led by cabin and acoustics teams. This will verify high altitude performance and ensure cabin noise stays below 48 dB. Then in flight test, we will perform long-range validation and short-field takeoff test, targeting 7,800 nautical miles range and 4,850 feet takeoff distance. Finally, the certification phase will include FAA certification activities and flammability testing to ensure compliance with Part 25 and FAR 25.853 standards. To wrap things up, we have validated the feasibility of designing the long-range business jet that not only delivers performance but also enhances passenger comfort and personalization. Throughout the process, we looked closely at existing market limitations, such as restrict range, lack of in-flight connectivity, and limited internal flexibility, especially for high-end travelers. We also evaluated a range of activities, especially in the propulsion system, where we focused on finding the best balance between thrust efficiency and noise compliance. Overall, our concept addresses the main needs of the luxury jet market with thoughtful design decisions across propulsion, cabin layout, and a clear path toward testing and certification.